Which statement is correct regarding a continuous flow fuel injection system used on many reciprocating engines? Fuel is injected at each cylinder intake port. The continuous injection of fuel takes place in the engine's intake port. Each time the intake valve opens, fuel is drawn into the cylinder. During the operation of an aircraft engine, the pressure drop in the carburetor venturi depends primarily on the air velocity. Bernoulli's principle states that as the air velocity increases, pressure decreases. As air flows through a venturi, the airspeed increases and pressure decreases. The device that controls the volume of the fuel-air mixture to the cylinders is called the throttle valve. The throttle valve is usually a butterfly type of valve which opens to allow more fuel and air into the induction system. It closes to restrict flow to slow down the engine. Which of the following causes a single diaphragm accelerator pump to discharge fuel? An increase in manifold pressure that occurs when the throttle valve is opened. The manifold pressure increases as the throttle is opened. A spring then forces the fuel out into the airstream. What is the purpose of the carburetor accelerating system? Temporarily enrich the mixture when the throttle is suddenly opened. The acceleration system is used when the throttle is opened quickly. The system sprays extra fuel, enriching the mixture, into the airstream because of the extra air being drawn in when the throttle is opened suddenly. Which of the following is least likely to occur during operation of an engine equipped with a direct cylinder fuel injection system? Backfiring. Because the fuel is being injected directly into the cylinders, there is no fuel in the induction system to cause backfiring. On a carburetor without an automatic mixture control as you ascend to altitude, the mixture will be enriched. If the mixture control is not adjusted as the aircraft ascends, the mixture will be enriched. This is due to the air density decrease as the aircraft climbs. What is the relationship between the accelerating pump and the enrichment valve in a pressure injection carburetor? No relationship since they operate independently. The accelerating pump and the enrichment valve are separate systems that work independently. What carburetor component actually limits the desired maximum airflow to the engine at full throttle? Venturi. The venturi diameter, at its smallest point, controls the maximum airflow into the engine at full throttle. What is the relationship between the pressure existing within the throat of a venturi and the velocity of the air passing through the venturi? The pressure is inversely proportional to the velocity. Bernoulli's principle states that as air velocity increases, pressure decreases. As air flows through a venturi, the airspeed increases and pressure decreases, so the pressure is inversely proportional. Select the correct statement concerning the idle system of a conventional float-type carburetor. The low pressure between the edges of the throttle valve and the throttle body pulls the fuel from the idle passage. The idle circuit in a float carburetor uses the low pressure created by the air flowing past the small opening between the throttle valve and the body. This is needed because there is not enough airflow for the venturi to operate. The economizer system of a float-type carburetor performs which of the following functions? It supplies and regulates the additional fuel required for all engine speeds above cruising. The economizer system operates to enrich the fuel flow at engine speeds higher than cruise. This allows the engine to run leaner at cruise RPM. The fuel level within the float chamber of a properly adjusted float-type carburetor will be slightly lower than the discharge nozzle outlet. The float level must be slightly lower than the discharge nozzle as the engine draws air. The venturi causes a pressure drop in the area of the discharge nozzle, allowing atmospheric pressure to push the fuel into the airstream. The metered fuel pressure, chamber C, in the injection type carburetor is held constant through the entire engine operating range. The pressure in chamber C is held constant and is used as reference to help meter the fuel flow. Select the statement which is correct relating to a fuel level check of a float type carburetor. Do not measure the level at the edge of the float chamber. Surface tension between the fuel and the wall of the float chamber makes the fuel level close to the wall seem higher than it actually is. A straight edge can be placed across the parting surfaces of the top of the float chamber and measure down to the surface of the fuel away from the edge. What carburetor component measures the amount of air delivered to the engine? The venturi. At full throttle, the venturi measures the maximum flow of the air into the engine. At lower RPMs, the throttle valve controls the flow into the engine. Where is the throttle valve located on a float type carburetor? After the main discharge nozzle and venturi. The throttle valve is after the main discharge nozzle and venturi. Fuel is discharged for idling speeds on a float type carburetor from the idle discharge nozzle. The idle circuit in a float chamber uses the low pressure created by the air flowing past the small opening between the throttle valve and the body. The desired engine idle speed and mixture setting is adjusted with engine warmed up and operating. All fuel type adjustments to the engine should be made with the engine at operating temperature and operating correctly. An aircraft carburetor is equipped with a mixture control in order to prevent the mixture from becoming too rich at high altitudes. The air density becomes lower as the altitude is increased. The mixture must be adjusted to prevent a rich mixture because of the decreased air density. Which of the following is not a function of a carburetor venturi? Regulates the idle system. Generally, the idle circuit has nothing to do with the venturi. Idle cutoff is accomplished on a carburetor equipped with a back suction mixture control by introducing low pressure intake manifold air into the float chamber. By creating a low pressure area in the flow chamber, the pressure pushing the fuel out of the discharge nozzle is decreased. This action stops the fuel flow because the atmospheric pressure is forcing the fuel out through the discharge nozzle is reduced. One purpose of an air bleed in a flow type carburetor is to decrease fuel density and destroy surface tension. The purpose of the air bleed is to atomize the fuel or mix the fuel and air more completely. By inducing air into the fuel, its density and surface tension will be reduced. To determine the float level in a float type carburetor, a measurement is usually made from the top of the fuel in the float chamber to the parting surface of the carburetor. The parting surface is generally used to measure the float level. The throttle valve of float-type aircraft carburetors is located between the venturi and the engine. The throttle valve is between the venturi and the engine. Why must a float-type carburetor supply a rich mixture during idle? Because at idling speeds, the engine may not have enough airflow around the cylinders to provide proper cooling. If a float-type carburetor leaks fuel when the engine is stopped, a likely cause is that the float needle valve is worn or otherwise not seated properly. What are the positions of the pressurization valve and the dump valve in a jet engine fuel system when the engine is shut down? Pressurization valve closed, dump valve open. The pressurization valve is closed because the engine is in the off or shutdown position. The dump valve is open because the fuel, which normally flows to the engine, is redirected from the engine. An excessively lean fuel-air mixture may cause an increase in cylinder head temperature. Lean mixtures at high power settings will cause the cylinder head temperature to run high because a lean mixture burns slower. This allows heat of combustion to remain around the cylinder longer and into the exhaust, increasing the temperature of the cylinders. A mixture ratio of 11:1 normally refers to 1 part fuel and 11 parts air. This is 1 part fuel to 11 equal parts air. There's always much more air than fuel. The economizer system in a float-type carburetor increases the fuel-air ratio at higher power settings. The economizer enriches the mixture at higher power settings and leans the mixture at cruise settings. This is needed because the fuel-air mixture at high power settings must be rich, cooling fuel, to help prevent detonation. A carburetor is prevented from leaning out during quick acceleration by the accelerating system. The accelerating system will increase the fuel flow during rapid increase in throttle opening. What effect does high atmospheric humidity have on the operation of a jet engine? Has little or no effect. Humidity has very little effect on turbine engines due to the high level of airflow. What could cause a lean mixture and high cylinder head temperature at sea level or low altitudes? Automatic mixture control stuck in the extended position. As the aircraft increases its altitude, the bellows will increase, goes toward an extended position, which is normally leaning the mixture to compensate for less dense air at altitude by use of the needle valve connected to the bellows. If the bellows sticks in the extended position at low altitudes, the engine will be running lean when it should be enriched. This will cause the engine cylinder head temperatures to increase. Detonation occurs when the fuel-air mixture burns too fast. Detonation occurs when the fuel-air mixture is ignited by normal ignition, but instead of burning at the predetermined rate in the cylinder, it explodes. This fast rate of burning does not give a smooth push to the piston, hence the power is reduced and the cylinder temperatures increase rapidly. What corrective action should be taken when a carburetor is found to be leaking fuel from the discharge nozzle? Replace the needle valve and seat. This leak is caused by the needle valve and seat, so replacing it should correct the problem. A major difference between the Teledyne Continental and RSA Precision Aeromotive or Bendix continuous fuel injection system in fuel metering is the Continental system uses fuel pressure only as a metering force. The RSA system uses both air and fuel pressure to meter the fuel to the engine. The Continental system uses a fuel pressure that is proportional to the engine's speed. This is accomplished by a fuel pump that is part of the metering system. The function of the altitude compensating or aneroid valve used in the Teledyne Continental fuel injection system on many turbocharged engines is to prevent an overly rich mixture during sudden acceleration. Continental fuel injection systems on engines that use a turbocharger have an upper deck reference line to an altitude compensating aneroid valve. The purpose of the valve is to prevent an overly rich mixture during sudden acceleration. The primary purpose of the air bleed openings used with continuous flow fuel injector nozzles is to aid in proper fuel vaporization. Air is drawn in at the fuel nozzles at the cylinder to better vaporize the fuel as it flows through the nozzles. Which of the following best describes the function of the altitude mixture control? Regulates the richness of the fuel-air charge entering the engine. At altitude, the fuel-air mixture must be lean due to the less dense air. The altitude mixture controls adjusts the mixture to compensate for air density changes at higher altitude. What is a function of the idling air bleed in a float-type carburetor? It vaporizes the fuel at idling speeds. The idle air bleed is to help atomize the fuel with air as it flows out of the idle discharge. It aids in emulsifying and vaporizing the fuel at idle speeds. If the volume of air passing through a carburetor venturi is reduced, the pressure at the venturi throat will increase. If the volume of the air passing through a venturi is reduced, the flow speed increases and the pressure drop will increase. Refer to Figure 2-9-1. Which curve most nearly represents an aircraft's engine's fuel-air ratio throughout the operating range? Number 2. It starts with a rich idle lean towards cruise power, and it is enriched at higher power settings. What will occur if the vapor vent float in a pressure carburetor loses its buoyancy? A rich mixture will occur at all engine speeds. If the float loses buoyancy, it will sink. The result will be a rich mixture due to the float not closing the needle valve and seat. Also, the float level at all speeds will be high. What method is ordinarily used to make idle speed adjustments on a float-type carburetor? An adjustable throttle stop or linkage. Idle speed is set by adjusting the throttle valve opening. A screw that hits a stop is adjusted to set the amount of opening of the throttle. For what primary purpose is a turbine engine fuel control unit trimmed? To obtain maximum thrust output when desired. Which type of fuel control is used on most of today's turbine engines? Hydromechanical or electrical? Modern engines use an electric type of fuel control, AVOTEK, that uses sensors to monitor the engine's parameters to schedule the fuel flow. Hydromechanical fuel controls are still used in many turbine engines. The mixture used at rated power in air-cooled reciprocating engines is richer than the mixture used through the normal cruising range. True. The mixture used at idle in air-cooled reciprocating engines is richer than the mixture used at rated power. True. An aircraft engine equipped with a pressure-type carburetor is started with the primer while the mixture control is positioned at idle cutoff. The engine is started with the mixture control in the idle cutoff position using the primer. As the engine begins to start, the mixture is moved to rich full power. The use of less than normal throttle opening during starting will cause a rich mixture. The throttle will block airflow into the engine, making the mixture rich and can make the engine hard to start. When checking the idle mixture on a carburetor, the engine should be idling normally. Then pull the mixture control toward the idle cutoff position. A correct idling mixture will be indicated by an increase of 10 to 50 RPM before decreasing. The RPM increase is due to the mixture passing through a leaner setting just as it begins to stop. This shows that the mixture is rich enough at idle. The purpose of the back suction mixture control in a float-type carburetor is to adjust the mixture by regulating the pressure on the fuel in the float chamber. Since the pressure of the fuel in the float chamber is a major factor in the amount of fuel that flows from the discharge nozzle, the back suction mixture control adjusts the pressure in the float chamber. Reciprocating engine power will be decreased at all altitudes if the humidity is increased. Dry air is denser than air with high water vapor humidity in it. By increasing the humidity, the amount of air, weight of charge, drawn into the cylinders is less and power is less. In order to stabilize cams, springs, and linkages within the fuel control, manufacturers generally recommend that all final turbine engine trim adjustments be made in the increased direction. What occurs when a back suction type mixture control is placed in idle cutoff? The float chamber will be vented to a negative pressure area. Negative pressure in the float chamber will stop the flow of fuel because the atmospheric pressure in the float chamber is decreased. When trimming a turbine engine, the fuel control is adjusted to set idle RPM and maximum speed, or EPR. This adjustment is to set at idle speed, correct throttle stagger, and most importantly, the set of maximum speed and EPR. A supervisory electronic engine control, EEC, is a system that receives engine operating information and adjusts a standard hydromechanical fuel control unit to obtain the most effective engine operation. This system uses both an electric and hydromechanical control. The electronic control can adjust the hydromechanical control. The electronic control senses more engine parameters and can adjust the control with much more accuracy. A full authority digital engine control, AVOTEK, is a system that receives all the necessary data for engine operation and develops the commands to various actuators to control engine parameters. With the full authority electronic engine control, parameters are monitored using sensors that transmit the needed data to the electronic control, which produces the outputs needed to control the engine through various actuators. The generally acceptable way to obtain accurate on-site temperature prior to performing engine trimming is to hang a thermometer in the shade of the nose wheel well until the temperature reading stabilizes. It is important to take the temperature as close to the aircraft as possible. It should be taken in the shade and not be affected by other outside variables. An aircraft should be facing into the wind when trimming an engine. However, if the velocity of the wind blowing into the intake is excessive, it is likely to cause a false high compression and turbine discharge pressure and a subsequent low trim. The wind, air, blowing into the intake will affect the pressure reading used to trim the engines. The extra air will tend to make the trim adjustments too low. Generally, the practice when trimming an engine is to turn all accessory bleed air off. Generally, the status of the engine bleeds will be set forth in the trim information from the manual. Many require that the bleeds should be shut off. A reciprocating engine automatic mixture control responds to changes in air density caused by changes in the altitude or temperature. The mixture control will respond to changes in air density, which includes both temperature and pressure changes. If a float-type carburetor becomes flooded, the condition is most likely caused by a leaking needle valve and seat assembly. On a float-type carburetor, the purpose of the economizer valve is to provide a richer mixture and cooling at maximum power output. The economizer opens just past the cruise RPM range. It allows for extra fuel to flow to the engine at high power cooling fuel, yet it reduces the fuel in the cruise range where extra fuel is not needed. Float-type carburetors, which are equipped with economizers, are normally set for their leanest practical mixture delivery at cruising speeds and enriched by means of the economizer system at higher power settings. If an aircraft engine is equipped with a carburetor that is not compensated for altitude and temperature variations, the fuel-air mixture will become richer as either the altitude or temperature increases. As the air density lowers, the mixture will become richer. Altitude and temperature are major factors in the density of air. The back suction mixture control system operates by varying the pressure acting on the fuel in the float chamber. The back suction mixture control operates by controlling the pressure above the fuel in the float chamber. It has a range from atmospheric to negative pressure, depending upon the mixture needed. A rich or lean mixture is accomplished by controlling the amount of negative pressure in the float chamber. If the main air bleed of a float-type carburetor becomes clogged, the engine will run rich at rated power. Anytime the air bleed is clogged, the engine will run rich. Since the idling system has its own air bleed, it should not be affected. Which method is commonly used to adjust the level of a float in the float-type carburetor? Add or remove shims under the needle valve seat. A commonly used technique to adjust the float level in the float-type carburetor is by adding or removing shims under the needle valve seat. What is the possible cause of an engine running rich at full throttle if it is equipped with a float-type carburetor? Clogged main air bleed. A clogged main air bleed will cause a float-type carburetor to run rich at full power setting. This principle is restricting the main air bleed at full power settings is used as a power enrichment system on some carburetors. An aircraft engine continuous cylinder fuel injection system normally discharges fuel during which strokes? All continuously. Continuous flow injection system discharge fuel during all 4 strokes. This is where it gets its name, continuous flow system. A rotary vane pump is best described as a positive displacement pump. The principal fault in a pressure-type fuel flow meter indicating system installed in a horizontally opposed continuous flow fuel-injected aircraft reciprocating engine is that a plugged fuel injection nozzle will cause a higher than normal fuel flow indication. When troubleshooting an engine for too rich a mixture to allow the engine to idle, a possible cause could be a primer line open. If the engine will not idle due to an excessively rich mixture and the idle mixture adjustment will not lean it sufficiently, there's a good chance that the primer valve is not closed and locked and open, allowing excessive fuel into the engine. Under which of the following conditions would an engine run lean, even though there is a normal amount of fuel present? Incomplete fuel vaporization. Incomplete vaporization of the fuel causes an excessive amount of air for the amount of vaporized fuel. This incomplete vaporization causes the engine to run lean even though the proper amount of fuel has been metered. If the idling jet becomes clogged in a float-type carburetor, the engine will not idle. If the idling jet becomes clogged on a float-type carburetor when the throttle is closed, there will not be enough fuel supplied to the engine for it to run at idle speeds. What is the final authority for the details of carburetor overhaul? The manufacturer's recommendations. When overhauling an aircraft carburetor, all work must be accomplished in accordance with the FAA-approved overhaul manual provided by the manufacturer. What factor is not used in the operation of an aircraft gas turbine engine fuel control unit? Mixture control position. Gas turbines do not have mixture controls. The active clearance control, ACC, portion of the EEC system aids turbine engine efficiency by ensuring turbine blade to engine case clearance are kept to a minimum by controlling case temperatures. The ACC portion of an ECC helps maintain peak engine efficiency by providing cooling air to the compressor case to keep turbine blade tip clearance to a minimum to ensure minimum pressure loss. By controlling engine case temperature, it controls expansion of the case. The fuel metering force of a conventional float-type carburetor in its normal operating range is the difference between the pressure acting on the discharge nozzle located within the venturi and the pressure acting on the fuel in the float chamber. The fuel metering force of a float-type carburetor is the difference between the pressure in the float bowl and the venturi pressure. The pressure within the venturi is determined by the amount of air flowing through it. One of the things a metering orifice in a main air bleed helps to accomplish at a given altitude in a carburetor is better fuel vaporization and control of fuel discharge, especially at lower engine speeds. The metering orifice in the main air bleed meters the correct amount of air to mix with the fuel just before the main discharge nozzle. This addition of air emulsifies the fuel. which makes the fuel evaporate better, especially at lower power settings. A punctured float in a float-type carburetor will cause the fuel level to rise and enrich the mixture. A punctured float in a carburetor will take on fuel and sink or partially sink, causing the fuel in the bowl to rise to a higher level. Fuel at a higher level in the bowl will enrich the mixture. How will the mixture of an engine be affected if the bellows of an automatic mixture control, AMC, in a pressure carburetor ruptures while the engine is operating at altitude? It will become richer. The AMC bellows has an insert gas sealed inside that is counterbalanced by a spring force that tries to collapse it. As altitude is increased, atmospheric pressure on the outside of the bellows decreases as the pressure within the bellows increases, overcoming the spring pressure and closing the needle valve. This causes the mixture to lean as altitude increases. If the bellows rupture, the atmospheric pressure will be the same inside as outside the bellows, allowing the spring to pull the needle valve back and the mixture to increase. When air passes through the venturi of a carburetor, what three changes occur? Velocity increases, temperature decreases, and pressure decreases. When air passes through a venturi, the velocity of the air will increase while the temperature and pressure decrease. What component is used to ensure fuel delivery during periods of rapid engine acceleration? Acceleration pump. During periods of rapid engine acceleration, an accelerator pump provides additional fuel needed. The device that controls the ratio of the fuel-air mixture to the cylinders is called a mixture control. Most reciprocating aircraft engines have mixture controls that allow the pilots to adjust the fuel-air mixture to the cylinders. At what engine speed does the main metering jet actually function as a metering jet in a float-type carburetor? All RPMs above idle range. In a float-type carburetor, the main metering jet meters the fuel in all RPM ranges above idle. The idling metering jet meters the fuel at idle. During engine operation, if carburetor heat is applied, it will decrease the air density to the carburetor. Carburetor heat increases the temperature of the air in the carburetor, thus decreasing the density of the air. During idle mixture adjustments, which of the following is normally observed to determine when the correct mixture has been achieved? Changes in RPM or manifold pressure. Engine RPM and manifold pressure are normally monitored during engine mixture adjustments. As an indication that the optimum idle mixture has been obtained occurs when the mixture control is moved to idle cutoff and manifold pressure decreases and RPM increases momentarily before the engine ceases to fire. The pilot will see a slight decrease in manifold pressure with a slight rise in engine RPM when the mixture is moved to the idle cutoff positions. This is an indication of the optimum mixture setting. When a new carburetor is installed on an engine and the engine is warmed up to normal temperatures, adjust the idle mixture and then the idle speed. When installing a new carburetor, the engine and carburetor should be brought to normal operating temperatures before adjusting the idle or mixture setting. One of the best ways to increase engine power and control detonation and pre-ignition is to use water injection. Water injection is commonly used on larger reciprocating engines to increase power and prevent pre-ignition and detonation at high power settings. In turbine engines that utilize a pressurization and dump valve, the dump portion of the valve drains the engine manifold lines to prevent fuel boiling and subsequent deposits in the lines as a result of residual engine heat at engine shutdown. The dump portion of the valve drains the manifold and fuel lines at the engine shutdown in order to prevent the boiling of the fuel due to the engine's residual heat, which can cause deposits that could lead to clogs. Which of the following is not an input parameter for a turbine engine fuel control unit? Ambient humidity. Ambient humidity is not a factor monitored by fuel control units. What types of carburetors are most commonly used on small reciprocating engines? Float-type carburetors and pressure-type carburetors, as well as draft and side draft carburetors. Where does a pressure injection carburetor obtain fuel pressure? From the engine-driven fuel pump. What position of the mixture control will stop engine operation? The idle cutoff position or full aft. If an engine is run at idle with the mixture in the full rich position, what problems could occur? The spark plugs will become carbon fouled and may even short out, leading to a rough running engine and high RPM drops during the magneto check. What are two basic types of turbine engine fuel control units? Mechanical, hydromechanical, and electric, and full authority digital engine controls, AVOTEK. What are some of the engine variables detected by a turbine engine fuel control unit? Power lever position, RPM of the different turbine sections, compressor inlet temperature, compressor discharge pressure, and EGT.